Got everything right? You sure? All right. So this is going to break up. We said it's going to break up. We know that because it's ionic. We know it's ionic because it's a metal bonded with a nonmetal. But it has to be both ionic and aqueous. Okay? If it's going to break up, we're going to break it up into magnesium and chloride. Okay? We need to figure out what charges to put on those. And you go to the periodic table with oxidation numbers in your test references, this document right here, and you can see that magnesium only has one kind of charge number. So I don't have to worry about figuring out the charge number. Please don't distract my class, okay? All right. Well, let's try to do it with a little less disruption, okay? All right.
What if it does have a different charge? Like, how do you decide?
You have to figure it out by some simple math. Okay? The same math we've been using for a month now, and I'll try and go through that with you in a minute, okay? So there's a 2 plus here. All right? We need to know which charge to use for the chlorine. Now, chlorine has about 6 or 7 different charges. Only one of those is negative. Okay? When we're putting together compounds like magnesium chloride, magnesium we know is 2 plus, and we need to know what charge to put on the chlorine. Okay? 2 plus, and there's only one of those 2 plus charges. And we're going to add that to the 2 chlorines. So we know what number to put in there so the equation equals 0. And it's a 1 negative. That's basically, Sydney, the same process you use for figuring out charges when there's more than one possible charge. Okay? So there's a 1 negative there. That means the chlorine's got to be 1 negative.
Choose the one that works for that.
Say what? We will. This 2 means I need 2 chlorides.
So that goes before the 2.
Right. So let me tell you this. Let me put it this way. When we were predicting the products of equations and then balancing those formulas, I said over and over again, as emphatically as I knew how, that subscripts don't travel unless they're part of what? Polyatomic ion. This is not a polyatomic ion. It's a single type of atom. Okay? So this subscript doesn't travel. Well, it doesn't travel down here either. Okay? It happens that there are 2 of them, but we don't put a subscript down here. We show it as 2 separate ions because those 2 separate ions have broken free from each other and from the magnesium.
So why do they travel down here? On the other one.
On what? Here?
We had 3. You brought 3 down there.
The 3 travels because it's part of a polyatomic ion.
Oh.
Subscripts don't travel unless they're part of a polyatomic ion. So when you look on the common ions list for some part of this formula here that is a polyatomic ion, you'll see nitrate is NO subscript 3. That 3 is going to move with it. Okay, and it's going to move with it down here. Okay, subscripts 2 on this chloride aren't going to travel. They're not going to travel over here. They're not going to travel down there.
So it doesn't matter which oxidation level we use.
It does. We still have to have a negative charge because we've got to have a 0 charge overall. You've got to have a neutral compound. So this is 2 chlorides with negative charges. Okay? Brenda, if this compound is aqueous, what physical states do I assign to these 2 ions? Aqueous. Alright, and I'm going to put a plus sign in between those. And I've broken up everything I need to break up on the left side. So now we're going to put an arrow and go to the right side. Okay? Morgan? What do I do with this compound right here? What? Why not? Oh, I hear somebody whispering over there. I want you to whisper when I'm talking, and now you're going to whisper to give people answers. Don't. They don't build muscles when you do it for them.
Yeah, they do. They build a lot. They build a little bit, don't they?
No. Help them out more by letting them figure it out. Okay? I appreciate what you're trying to do. I really do. But they can't do it for themselves if they're not allowed to do it for themselves. Okay? So Morgan, am I going to break it up?
No, because they don't follow either
Well, yeah, right. They have to be aqueous. In both cases, whether it's ionic or it's acidic, it's still got to be aqueous. That's not aqueous. What are we going to write down here then? The same thing that's up there. Okay? Thank you, Morgan. Yes.
Where you say if you can't be quiet, you can stay after school. You mean you don't have to?
Well, that's your choice. If I write you up and you don't show up after school, you're gonna stay for the principal. If you don't stay for the principal, you're gonna get out of school suspension.
Okay. I was just asking a question.
There you go. Okay. All right. Let's see, Kella. What am I going to do with this right here? Okay. What am I going to break it up into?
You're going to put the MG not so.
Okay.
You're going to put a charge on it.
What charge am I going to put on it?
You're going to put a P+.
Okay.
And you're going to put that aqueous.
Okay.
And then you can bring the NO3 over. And
If it's going to be broken up, it's got to have a charge. Don't tell her the answer. What did I just get through saying?
It's a habit. I'm sorry.
You know, I got some duct tape back there somewhere in a drawer.
Is that black duck?
Huh? Negative. Anything else? Okay, am I done now? Are you giving her answers now, Katie? What do I do with that 2 right there? Huh? Probably. All right, why do I put it in front?
Because now that it's broken up, you can put it in front of the coefficient because it doesn't have to single just the NO3 out with the parentheses because NG's not part of it anymore.
Okay, I'm not sure that's really very clear. Let me try to make it a little bit clearer, okay? It might work for you, but it might not work for everybody else. Let me see if I can make it clearer. When I write this formula, these subscripts are communicating to CJ and everybody else in the room that this nitrate ion is bonded to this magnesium and to each other. The whole thing's bonded together. If I break all that up, if I take those nitrates and pull them apart and pull it apart from the magnesium, they don't put a subscript there anymore because they're not bonded together anymore. They're separate, so you use a coefficient. Does that help you? We do put a plus right there. All right, now that's a complete ionic equation. Okay?
Oh, another question.
Yes.
Is you gonna just gonna give us the equation for us to break up and overgrab the field equation and then break it back up?
Well, I have to at least give you the reactants like I did last night.
No, that's what I'm saying.
Yeah. So I might only give you the reactants. You have to do everything else. Let's move on. All right, now you need to write a complete ionic equation. I mean a net ionic equation. Okay? How do you do that? What do we have to do?
Figure out which stays the same.
Exactly the same. Not a little bit the same. Exactly the same. So please do that. Now, if you're going to mark them out, don't scratch them completely out. One diagonal line is all you need. One diagonal line is all you need. Anybody want to volunteer to do this for everybody?
I do it, but I ain't gonna guarantee it'll be right.
Yeah. All right, come on up here and do it. We're going to have a guest teacher. And she's going to do it while I explain it. How about that?
No, I should get on YouTube, man. I ain't on YouTube.
All right.
First of all, you mark them out.
All right, she's marking out the common ions, the ions that are exactly the same on both sides. The nitrate has a 2 negative charge. It's aqueous. It's exactly the same. Anything else?
No.
A and G, yeah.
No, it's not all of it the same.
And G's exactly the same.
Not this together.
Huh?
This together. Oh.
There you go, there you go. So Mg, 2 plus charges, aqueous, it's exactly the same on both sides. So now we're ready to write the net ionic equation of this. We're going to rewrite everything that's there except for those ions we just crossed out. So would you do that for me, please? Here, let's use the black marker here. CJ says black is beautiful. We're going to do the black marker here. Yeah.
It is.
Well, if you'll hang on a second, I'll show you how to do that. Okay? All right?
Is this right before we put this on the paper?
Don't do that,
That's it?
honey.
That's it? Yeah, you get to choose.
Man, I wanted to be a star, and I wanted to be
Are you there?
All right. So this is indeed right. Now, if you will get out your Unit 5 handout, please. Get out your Unit 5 handout. Okay? If you have the complete handout, that's what your last printed page is supposed to look like. So CJ, and anybody else who's struggling with predicting products, look how many problems we have on here that you can practice with.
I mean, I feel balance like this is the second part of the ball.
Okay?
I could do it.
Okay, listen to me. Whatever you're having problems with, that's practice right there. So what you do is you go home, you try them, bring them in, and we'll go over them real quick, and you'll know whether you got them right or not. Yeah.
I'm not dead serious. I don't want to practice because what I'm doing is
I don't want to practice. Now, what would Coach Gutshaw say if you told Coach Gutshaw that you didn't want to practice?
Oh, good.
I'm saying.
I'm saying.
The second point. I'm saying. Like, I can do the whole first point. When it comes to like putting it down on paper, I don't know what to do.
Try it. Bring
I'm
it
gonna
in.
try it, but it's gonna be wrong.
Well, then bring it in. Come in, I'll help you. All right? Look, right here.
Like, look, I could, like you be like balancing and all that.
Do it.
Go over the food. over.
CJ, I would love to be up here to help you individually. I really would. Okay? I will help you as much as you'll give me a chance to help you. All right? I'm here on Friday. Okay? All right, now, I have meetings I got to go to. If you want to come in on Friday, I'll cut out some time for you to come in and I'll help you on Friday. Okay? All right, now, we are going to retake the Unit 5 test on Monday. We're going to retake the Unit 5 test on Monday. Not the same questions, same type of questions.
Similar.